Hi, welcome. This is lesson 7.1 on parallel lines, the theorems around those. We're going to jump right into this. First of all, transversal is a line that intersects or crosses two other lines. So you might see an example like that. This we might call T, that transversal, that's that line that crosses these other two lines. We have parallel lines. So I might say, let's say this is line M and this is line N. And I can say M with two straight lines and N. That means this M is line M. These two symbols mean is parallel to, and then the N over here, line N. And this that the symbol that means is parallel, but in the picture form, these two little arrows in the middle of a line mean that those two lines are parallel. And so we might say that they are crossed by this other line, and so we call it T. You could call it whatever, but I like to call it T because it is a transversal. So line M and line N are parallel, and they are crossed by the transversal T. So when you have parallel lines, certain things happen. Corresponding angles have the same orientation with respect to the vertex. Let me explain what that means. Angle 1 here is with respect to that vertex up and to the left. And so if we go to the other vertex, up and to the left would be angle 5. And they are congruent. And so I can say angle 1 is congruent to angle 5 because they are corresponding angles. Okay? Angle 1 and angle 5 are congruent. They are corresponding angles. When you have parallel lines, they have to be parallel lines. So if I go to angle 2 is up and to the right. And so if I go to the next vertex, up and to the right would be angle 6. And so angle 2 is congruent to angle 6. And then I've got, let's use a different color. Let's go to blue. Angle 3 down, down and to the left is 3. So on the other side, down and to the left from the other vertex is angle 7. And so I can say that angle 3 is congruent to angle 7. And the congruent symbol is just an equal sign with a little curvy line on top. And then angle 8 angle 4, which is down and to the right, and down and to the right on the other vertex is 8, so angle 8 and angle 4. When a transversal is cut, or when a transversal cuts into two other parallel lines, the corresponding angles are congruent. And so I can say angle 4 is congruent to angle 8, which just means their angle measures is the same. Alternate interior angles. angle 3 is on one side. Oh, say first off, let's just highlight the fact that interior means inside. And so when you're talking about inside, we're talking about the inside part of between the two parallel lines. So those are the angles on the outside. 1 and 2 are not, 7 and 8 are not, but 3 and 4 and 5 and 6 are. And so we can say that alternate interior angles, one is on one side, like the 3, and then we go to the other side and down. That's what alternate means. So 3 and 6, and they are also congruent. And so I can say angle 3 is congruent to angle 6. And then I can say 4 is on one side of the transversal, and 5 is on the other side of the transversal. And so angle 4 is congruent to angle 5. Alternate exterior angles. Well, first of all, again, this word exterior means outside, and so it's referring to the angles that are on the outside of the parallel lines. These are the points that are exterior for those two parallel lines, and they include the angles 1 and 2, 7 and 8. They do not include 3, 4, 5, or 6. And so alternate, just like before, just means it's on one side or the other, up or down. And so if I look at angle 1, that's an exterior angle. It's on one side of the transversal. If I go down to the other side, angle 8, they are also congruent. So angle 1 is congruent to angle 8 because of the alternate exterior angles postulate. It's just a fancy word, postulate. It means something that you can use in a proof. And then if I look at angle 2, it's on the right side, an exterior angle. The other side, exterior angle 7, is on the other side of the transversal, but it's down on the bottom. And so those are alternate exterior angles. And I can say that angle 2 is congruent to angle 7. Consecutive interior angles. Again, internal, they're interior, meaning they're on the inside. Consecutive refers to same side. But this time they're not congruent. So if I look at 3 and 5, these are consecutive interior angles. But the measure of angle 3 plus the measure of angle 5 is 180 degrees. They're supplementary. That's what that means. They're supplementary. If we go to 6 and 4, those are consecutive interior angles. And so the measure of angle 4 plus the measure of angle 6 is also 180 degrees. All right, so far so good. Properties, the transitive property. If A equals B and B equals C, then, one way that you could write this is if A equals B and B equals C, then A equals C. Vertical angle theorem. If two angles are vertical angles, then they are congruent. They have the same measure. Remember that from our last unit that this angle and this angle are vertical angles, as are this angle and this angle also vertical angles. And so if they're vertical angles, then they are congruent. So vertical angles are from intersecting lines. And it can be anything. It could be like this as well, or it could be straight up and down like that. The opposite pairs are congruent. All right, corresponding angle postulate. If two parallel lines are cut by a transversal, then each pair of corresponding angles are congruent. If two parallel lines are cut by a transversal, then each pair of alternate, and because this is the alternate interior angle theorem, each pair of alternate interior angles are congruent. And that does it for today. Good luck with your homework. We'll see you soon.